Welcome back. Let's continue. Still, there's a third difference when it comes to nitrogen. Potassium nitrate supplies nitrogen under the form of nitrogen. But there are also other nitrogen sources like urea and ammonia. And that will be in this block the topic, the comparison of the different nitrogen sources. I will show you 5 arguments that are required to come to the right selection of the nitrogen source. And this selection is based on plant physiological and salinity conditions. The key points to consider are sensitivity of the plant to ammonium nutrition. Secondly, the temperature range in the root zone. Thirdly, the physiological states of the plant. The presence of cell and growing conditions. And as a 5th point, water use efficiency. I will go one by one and explain the impact of a certain selection of the nitrogen source on their typical characteristics. Let's start with the first one, the selection of the nitrogen source and the sensitivity of the plant to ammonium nutrition. When it comes to the selection, nitrate is always known as a quick-acting nitrogen source, as it's directly absorbed by the plant. And that is shown in this figure. If we would apply urea, in particular when it's applied on top of the soil, then the nitrogen can easily get volatilized, and urea is also prone to leaching. Urea has no charges, so it will not get fixed to soil particles, let it be clay or organic matter. When urea gets hydrolyzed in the process of ammonification, it will be transformed to ammonium, NH4. Again, under alkaline soil conditions, ammonium will lose one of its H+, becomes ammonia, which is also a volatile component. A positive thing of ammonium can be that it can get fixed temporarily by clay soils. Clay soils have a negative charge, ammonium a positive charge, so positive and negative will be joined together to the soil clay particles, and that will prevent ammonium from being leached under rainy conditions. At the same time, it's unknown when this nitrogen will become available again for plant uptake. As a third step, ammonium nitrogen will get converted into nitrate by soil bacterial processes, and in fact nitrate is the main form under which plants absorb nitrogen. So even if you would start with organic manures, through these various steps it will end up in nitrate, and that is the way plants predominantly absorb nitrogen. Now, with all this risk of losing or nitrogen getting fixed to the soil, why not apply immediately a nitrate nitrogen source? Nitrate is mobile in the soil and will be easily absorbed by the plant. It must be noted that also nitrate, as a mobile source in the soil, can also get leached. But here, that is not the blame, so to say, of the nitrate ion. Leaching has all to do with your irrigation management. You should irrigate according to the plant's demand. You should not start leaching the soil with irrigation water. Ammonium, with a positive charge, starts competing for the uptake with the other ions with positive charge. Calcium, magnesium, potassium. So that's what we call antagonism. Ammonium partly blocks the uptake of calcium, potassium and magnesium. On the other hand, nitrate with its negative charge synergistically helps in the absorption of positive charges like calcium, magnesium, potassium. And that's the beauty of using a nitrate source. At the same time, feeding the plant with nitrogen, also feeding the plant indirectly with calcium, magnesium and potassium. This effect was shown in a study in Spain, where they confirmed that the greatest nitrogen uptake efficiency was with nitrate compared to ammonium. If we look at the slide on the left side, it shows the uptake after a single addition of nitrogen, isotopically labeled nitrogen, in a sandy soil. There was a single application and pots of 1000 liter volume in which citrus trees were grown. And it was shown in time that if you follow the blue line, which represents nitrate, that there was a much higher nitrate absorption in the case of nitrate than in the case of ammonium. A similar effect was shown on the right side in loamy soils, but less predominantly present compared to the one in the sandy soil. But still, there was a benefit of nitrate over ammonium. In particular, in the 90s, a number of studies have been conducted to show that ammonium reduces the uptake of calcium, potassium, magnesium compared to nitrate. In this graph, and you can see the reference of the bottom, a scientific study. You're free to get a copy from us or download it by yourself through the internet. Here, different ratios of nitrate to ammonium were used in the test in order to study the uptake of phosphorus, potassium, calcium, magnesium. When the ratio was 3 to 1, 3 nitrate to 1 ammonium, you can see that the highest uptake of these nutrients was found. A decline in uptake was shown at a 1 to 1 ratio, but when ammonium was the predominant nitrogen source, with 3 units of ammonium to 1 of nitrate, then hardly any of the 4 nutrients were being absorbed. And that is clearly shown in the decline of these 4 graphs. Similarly, excess of ammonium reduces fruit yield and fruit quality in terms of Brix of muskmelon. Here again we had a ratio study, and if we look at the x-axis, you see on the left side 12 nitrate to 0 ammonium, 10 nitrate to 2 ammonium, 8 nitrate to 4 ammonium, and a 1 to 1 ratio, 6 of each. Interestingly, when all nitrogen is being applied under the nitrate form, many times not the optimum yield or amount of sugars are being achieved. Some ammonium is beneficial for plant performance, and the explanation for this is that some ammonium acidifies the rooting zone, making micronutrients more available for plant uptake. Iron, manganese in particular benefit for a more acidic nutrient, more acidic rooting zone. And that is translated into better crop performance. If we look at this graph, we see that the ideal ratio is 10 units of nitrate to 2 units of ammonium. The red line represents the degrees of Brix, the sweetness of the fruit, so to say. And the blue line, the yield. The blue line is on the y-axis on the left hand, and you can see that best yields were obtained in the ratio 10 to 2 to 8 to 4. But when it comes to the degrees of Brix, the sweetness of the fruit, there was already a decline when a ratio of 8 to 4 was being applied. I included a slide of blueberry because all of us think that blueberry doesn't like or tolerate nitrate, and that is not true. It's shown in this study by 2 Japanese researchers, the reference at the bottom of the slide again, which clearly show that the ideal ratio between ammonium and nitrate nitrogen is a 1 to 1 ratio, both for rabbit eye varieties and high boost varieties. The highest amount of plant dry rate was achieved with this ratio 1 to 1. And therefore also nitrate has to be part of the fertilization program. Remember, if all the nitrogen would be applied as ammonium, then it has to be applied, for example, as ammonium sulfate. Ammonium sulfate has a high EC value, a high salinity index, if you want to say. And blueberry, with its very poor rooting structure, is very sensitive to salinity. So if we think that all the nitrogen should be under the ammonium form, because blueberries thrive best under acidic soil conditions, then we will increase too much the salinity, and that will negatively impact plant performance. So for blueberry, when the soil conditions are sufficiently acidic, in between pH levels of 4 to 5, feel free to have half of your nitrogen demand under the nitrate form. Here nitrate will help for the uptake of calcium, magnesium, potassium, to have larger sized berries, and also berries that are more resistant to transport. Blueberries are delicate fruits, and calcium is essential for stronger cell walls. Better turgor is being caused by having more potassium, so have some nitrate in the program. Excess of ammonium will increase blossom end rot and at the same time reduce the leaf calcium content in tomato. This was shown by a study by Messi et al. The reference is at the bottom. You can see that when 100% of the nitrogen is applied as nitrate, there was no blossom end rot, and at the same time there were 1.8 units of calcium in the leaf. When we reduce the nitrate input to 80% and increase ammonium from 0 to 20%, then in this test already 24% of the fruits, tomato fruits, showed blossom end rot. And at the same time the calcium content in the leaf reduced to 1.5. And when the nitrate content was reduced to 60% and we had 40% of ammonium nitrogen, then almost half of all the fruits showed blossom end rot, and the calcium content in the leaf reduced from 1.8 when there was no ammonium in the program to only 0.9 units when there was 40% of ammonium nitrogen in the program. So what could be a practical recommendation when it comes to soil-grown crops, those that are not sensitive to chlorosis? We could have less than 20% of ammonium nitrogen and more than 80% of nitrate nitrogen. Crops that are sensitive to chlorosis like cucumber, rose or gerbera, we can increase ammonium content up to 50%. Make sure that those crops that are sensitive to chlorosis apply or an acidifier or a higher contribution of ammonium to prevent micronutrient deficiency like iron or manganese deficiency. And soilless grown crops, hydroponics, we have seen that certain crops like tomato, sweet pepper and melon are very sensitive to blossom end rot. So in that case, only have a minor percentage of ammonium, up to 5, maximum 7% in the nutrient solution, and 93 to 95% under the nitrate form. For crops grown in hydroponics sensitive to chlorosis, you may increase the ammonium proportion to a maximum of 15%. This would be for crops as cucumber, rose and gerber. Thank you very much for your attention. It was great being with you today, and I hope you will use all this information to the benefit of the crop. Thank you.